Last video for this section is going to combine all of the things that we've done in this unit together into one thing, which we are going to be doing inequalities that have absolute values in them. And so it's very important to remember that absolute value of numbers and statements or statements, all of that is going to be mixed together into one set of problems. So let's just get right into it right away. This is what we're going to be looking at in this section. So we have 4x, the absolute value of that, is less than positive 8. And if you remember from our last set, there was two steps that we had to do in every problem. We had to remove anything from the side with the absolute value. So in this case, there is nothing else near the absolute value, so step 1 is already done. Step 2 is we then had to set up the positive and negative solutions. And in this case, we have an equation that has an inequality in it, so it's going to be a little bit different here. So for Candy on this video, you're going to go down to step 2 where it says set up the positive and negative solutions, and there's a few little weird ways that I remember if we are looking at an and statement or an or statement. This one is a less than statement, so I think of less than, and so if I see less than, I see less than statement, and that's how I remember, less than. So in this case, we're going to set up the positive and negative solutions, and we will get 4x is less than or equal to 8, and because it's less than, I'm going to do 4x and negative 8. But what's important in inequalities is to remember that I'm multiplying this side by negative 1, and because I'm multiplying one of the sides times negative 1, I have to flip the sign on the negative solution side. Now, right, because I'm already writing this down, less than, I think of great or. So less than, great or, that's how I remember. But now that we have the and statement set up, we can simply just solve this inequality like we've been doing. I'll divide both sides by 4 to get x is less than or equal to 2. And I will divide by 4 again to get x is greater than or equal to negative 2, which means when I shade, I'll shade between 2 and negative 2. So even though these are hard equations, nothing in this section is really different except when we're setting up the and or the or statements between, trying to remember. Couple really big hints that everybody messes up. So big mistakes that people make all the time. Okay, mistake number 1 is they mix up and an or, which is why I do the less than, great or to try to remember. But it's still easy to mix that up. And the second and most common mistake is people don't flip the sign on the negative side. So right here, because we are multiplying that side by negative 1, we have to remember to flip the sign on that side. So now we have basically the same equation, except we have a great or symbol between. And so we remember that because it is great or, we are going to set up the positive and negative sides just like we did before, except that we will have an or statement between them this time. And we'll be very curious to see how that changes our final answer. Remembering that because this is a negative, we are going to flip the sign, and then we get x is greater than 2, or x is less than negative 2. Therefore, greater than 2 goes this direction, less than negative 2 goes this direction, and there's our set. If we notice on the problem before, we set up the numbers in the same spot, but we shaded between them. And now on this one, because we're doing an OR statement, we're shading in the opposite direction. So this kind of validates when we went back to section 4, that question of why do the OR statements kind of fork out and why do the AND statements usually go in. It's a lot of times because of absolute value. So now let's do a little bit harder equation. Now we have everything moved away from the absolute value sign, so we can immediately set up the positive and the negative sides of our equation. I notice that our symbol between is greater than, so we remember that it's great or. So we are going to be doing an OR statement between our equations. So I end up getting 3c plus 3 is greater than negative 9. And in this case, 3c plus 3 is less than positive 9 because I flipped the sign because I multiplied this number times negative 1. Now, some of you might notice that in the last section, if this number was a negative, it meant the equation was incorrect. That is not true if we're doing a greater than or less than symbol, because it can be a wide range of numbers instead of needing to be just the positive numbers. So the absolute value needing to be positive is only true if you're doing a straight equation, not an inequality. So it works just fine in these problems. Now I'm going to solve this equation like I've been doing. And because we've solved equations so many times in this section, if you notice every video I go a little bit quicker because my assumption is at this point, once you get to these steps, you're probably doing very, very well on the actual solving. It's just all about, can we set up the problems and make sure we get the new information set up correctly. This is not an X here. There we go. So C is less than 2. So because it's an OR statement, we're hoping that it's going to fork out in opposite directions. So we are going to do greater than negative 4. And we're going to less than 2. But I notice it didn't fork out the way that it normally does. And that's because when we pointed out that this part right here needed to be greater than a positive number, we have to remember that the answer of this is always going to be positive. So it's asking for what values of C will give us an answer that's greater than 9. The answer is, if we notice on our shading here, it's every value of C will work. The nice thing, though, about these problems is that you can still do the same solutions that you normally would have done. It just makes the shading a little bit strange at the end. So now let's do an equation where we have to get the number away from the right side of our equation right away, which means I have to divide by 4 before I start, and I get 2x plus 6 is less than or equal to 5. Now I have everything away from my absolute value sign, and I can set up my positive and my negative sides of the equation. But I have to decide, is this an AND or an OR statement? And I look at this and I see a less than statement, so I remember that it is less than. Therefore, we are hoping to shade between our two numbers for this problem. So I'm going to do 2x plus 6, is less than or equal to 5. And I'm going to do 2x plus 6 is greater than or equal to negative 5. Remembering to flip the sign because I multiplied this times negative 1. From here, I can solve my problem. Whoops, that should be a 6. To get 2x is less than or equal to negative 1. So x is less than or equal to negative 1/2. And on the right side, I'm going to subtract 6 from both sides. I get 2x is greater than or equal to negative 11. So x is greater than or equal to negative 11 halves. So then I shade. Negative 1/2 is right here. This is a closed circle. And I go negative, this is negative 5.5. So that'll be right there. Closed circle. And I'm going to shade between them. So unlike last problem, there is nothing else to do. This ended up working out just fine. This is a tough section with a lot of different steps. Once again, I'm going to show you how to check your answers using Wolfram Alpha. For now, though, if you have any questions, make sure you let me know.